Alright, in this lesson we will discuss simplifying rational expressions. Alright. To a degree, when you think simplifying rational expressions, you want to kind of associate that with what we do with reducing fractions. Okay, now let's look at our first problem, our first example. We have a negative 9 over 18 x squared y. Alright, now in the sense of looking at it like a fraction, negative 9 over the 18, okay, and then you could also say this would be like saying times 1 over x squared y. Okay, well, the negative 9 over the 18 reduces because 9 goes into 9 and 9 goes into 18, so 9 goes into itself one time and 9 goes into 18 two times. Alright, and there's nothing to be simplified or reduced, so to speak, in this second over here. So really all you do is just multiply and multiply, and what you end up with is a negative 1. Negative 1 times 1 is a negative 1, and then you have 2 times the x squared y, so 2 x squared y. That's all it is to it. Alright, let's look at another one. Let's see, let's try one like this. Here we go. So let's say negative 28 a squared b squared, alright, over negative 63 a squared b to the third. Okay, so if you'd like, again, this is just a way you can do it. If you choose to do it this way, you can separate the coefficients from the variables. So you can separate the coefficients, and then you can separate the variables. Okay, so you can write it like that if you'd like. Alright, now when we look at this part here, we know 28 doesn't go into 63 evenly, but we know 7 goes into both of these numbers, and a negative over negative is a positive, so when I reduce this fraction, it's going to be in a positive form. Okay, so that reduces, 7 goes into the 28 4 times, 7 goes into 63 9 times. Alright, so now when I look at my variables, I have a squared in the numerator, a squared in the denominator. So the same variable to the same exponent in the numerator and denominator just cancels, or in other words, you say 2 minus 2, because for division you subtract the exponents. So 2 minus 2 is 0. A to the 0 means basically that you have just 1, or in other words, the a squares cancel. Okay, so those cancel. Now here you have b squared in the numerator, b to the third, b cubed in the denominator. Alright, so you can basically, what I typically do is just say the bigger number minus the smaller number when it's in the fraction form, because that means division. So for division, again, we subtract the exponents. So 3 is the bigger number, so 3 minus 2 is 1. Bigger number minus smaller exponent, bigger exponent minus smaller. 3 minus 2 is 1. And because the bigger exponent is in the denominator, I write my answer in the denominator. So b to the third minus b squared is b to the first, and because my b to the third is the bigger exponent of the two and it is in the denominator, I write my b to the first, which is just a b, in the denominator. And because the 2 up here are gone in the numerator, I just write a 1. Okay, alright, and so you can see why Here, I'll write it a different way. Alright, I'll take this and write this a different way. I could have written it as a squared over a squared times a b squared over a b squared times a 1 over a b. Alright, I had two a's right here, right? A squared, there it is. A squared, there it is. Those cancel. Alright, b squared, here we go. Now I had b to the third here, but I put two of them here, so they'll show you that they'll cancel with 1 here left over. So 2 plus this 1 gives me my 3. Alright, so that means this is left over. Okay, so I have my 4/9 from this part and my 1 over b from this part. Alright, so bring that together and you end up with 4 times 1, which is 4, and 9 times b is 9b. Alright, so 4 over 9b. Okay, look at one more. Let's see if we can find a good one. Alright, let's try this one. Let's go with 60 x to the third z over negative 64 x y z squared. Okay, so you can write the coefficients, and then because I have an x in the denominator, I'll write an x, and then I'll write the other two x's because I had x to the third, and because I don't have any more x's to count for it, I just write a 1. Alright, so there are my 3 x's, right? And then for y, I don't have any y's in the numerator, so I write my 1, and then here's my y in the denominator. And for z, I write my 1z right here, and I write a z down here to account for it. But because I have two z's, I can say another z and right there. So 60 and the 64, what is that going to be? Am I looking at 3? What is that? What am I thinking of? 2, 4. Alright. Alright, so 4. Let's pull a 4 out right here. Okay. So if I'm pulling a 4 out, reduce 60 over 64 by 4. Alright, 60 divided by 4 is 15. And 64 divided by 4 is, what is that? 16. Still negative. These x's cancel, leaving me x squared over 1. Alright. Still have my 1 over my y. These z's cancel, leaving me 1 over z. Okay. So when I bring it all together, negative 15 x squared over 16 y z. Okay. Alright, negative 15 x squared over 16 y z. Now again, another way to look at it is when you look at your x's, alright, you have x to the third and x to the first. So you say, because it's division, 3 minus 1 is 2. So x to the third minus x to the first is x squared. And because your higher exponent between the x's was in the numerator, you write your x squared in the numerator. Alright, y. Well, you only had a y in the denominator, so it stays there. You didn't have anything to do with it. And with your z's, you had a z to the first and a z squared. So you say your bigger minus smaller, z squared minus z to the first. So 2 minus 1 is 1. Alright, and remember, even though you don't see a 1 here, it's understood that there's a 1 for an exponent. Anytime you see a variable, if the exponent is not shown, it's understood to be 1. Okay, so 2 minus 1 is 1, and because the bigger exponent is in the denominator, then you'd write your z to the first in the denominator. Alright, so this would be your answer here. Okay. Alright, let's look at some just a tad bit more complex. So now let's look at one like x squared plus 4x over x squared minus 16. Alright, so now that we're no longer dealing with monomials, so here we're dealing with binomials, and you know, these polynomials could stretch into trinomials, 4 terms, doesn't matter. Alright, but they're not monomials anymore. Monomial meaning a one-term numerator, one-term denominator. If we notice now, we have 2-term numerator, 1, 2, 2-term denominator, 1, 2. Okay? Alright, so now when we change or shift from dealing with monomials, we want to look to see if we can factor first. So we want to look to factor and cancel. Alright, so this here, excuse me, we want to see if we can factor. And when I look at the top, I see I have an x in the numerator. I see I have an x in both terms, so I pull an x out, and that leaves me with x plus 4. Okay, if I pull an x out of this, alright, if I pull an x out of that, it just leaves me an x. And if I pull an x out of this, it just leaves me a 4. Alright, here's the x I pulled out, and that's the x that's left here when I pull an x out. That's the 4 that's left here when I pull out an x. Alright, over. Down here, this quadratic. So I look to see if I can factor using what I would typically call reverse FOIL. And I realize that I'm dealing with a difference. Subtraction means difference of 2 perfect squares. X squared and 16 are both perfect squares. So I just take the square root of x squared, which is x, and I write it in the first position of both of my binomials because x squared is in the first position. Then I take the square root of 16, which is a 4, and I write it in both of the last positions of my binomial because my 16 is in the last position. And because I'm trying to get to a negative 16, I write opposite signs. So there we go. So if I checked it, first times first would give me x squared, last times last would give me a negative 16. If I combine the outside, which is a negative 4x, with the inside, which is a positive 4x, they would cancel. Thus, there's no middle term. That's why you only see binomial, 2-term quadratic here, x squared minus 16. Okay, so factors here would be x plus 4, x minus 4. Alright, so now when I look, I see I have common binomials top to bottom, so they can cancel. And what that leaves me with is x in the numerator, x minus 4 in the denominator. You cannot cancel this x with this x down here. This is a binomial and is not to be broken up. Okay, the only way you can cancel this binomial down here is if you had x minus 4 in the numerator as well. Alright, you can't just say x and x would cancel and leave you with a 1 over 4, negative 1/4. Doesn't work that way. You can't break up this binomial. Alright, so that's the answer there for us. Okay, one more. Let's say we have 4x squared plus 12x plus 9 all over 2x plus 3. Okay, alright, so again, we're dealing with multiple term polynomials. They're not monomials anymore. There's a trinomial in the top because it's 3 terms, right? 1, 2, 3 terms. And we're dealing with a binomial in the denominator because we have 2 terms. Alright, 1, 2. Okay, so we want to see if we can factor. And when I look at the denominator, I typically look at the easiest one first. When I look at the denominator, I see there's nothing to be factored in the denominator. Okay, so it's prime, let's say. Alright, so now in order for me to simplify this problem, I have to be able to find a way to cancel this 2x plus 3. So the only way I can cancel this 2x plus 3, since it's not factorable, is by having a 2x plus 3 as one of my factors for this trinomial up here. So I can kind of take a shortcut, let's say, with trying to figure through the factors of this by just writing 2x plus 3 as one of my possible factors. Okay, so I say 2x plus 3. Now I need my first times my first to give me this 4x squared, so I put a 2x here because 2x times 2x is 4x squared. And I'm trying to get a 9 for my last term, so my 3 in last position here times another 3 positive in last position here gives me my 9. And when I do outside, that gives me a positive 6x. When I multiply inside, it gives me a positive 6x. And 6x plus 6x gives me the 12x's in the middle. So I'm fine. So once I've factored, what I'm looking at is 2x plus 3 times 2x plus 3 over 2x plus 3. Alright, so this 2x plus 3 will cancel that 2x plus 3 and leave you with just 2x plus 3. Okay? And that's really all it is to simplifying rational expressions. All you're looking to do is factor when you can. Okay? Whether it be reverse FOIL, or you may have to pull something out like we did here. This is an example where we factored something out first. Okay? Or our reverse FOIL, which is this and this. These are examples of our reverse FOIL. Okay? But again, as long as you're dealing with something other than monomials, you're looking to try to factor and cancel top to bottom. Alright? Okay, at this time we will now conclude this session.